Thank you for joining the May 2024 VMware TAM customer webinar. This webinar is organized by the VMware TAM organization to provide our customers the opportunity to interact with great speakers about content that will help them get the full benefit from their VMware software. Before we get into today's content, there are a couple of announcements. Our next TAM customer webinar will be on June 6th, and we will have the privilege of being joined by Jason Messe to talk about vVols and core storage. Your interaction during this webinar is important, so please make use of the Q&A feature of Zoom to ask your questions. If we're unable to answer your question during this webinar, please be sure to reach out to your TAM and ask them to follow up. At the end of today's session, you'll be prompted to fill out a short survey about this webinar and any topic suggestions for future sessions. Your completion of the survey helps guide future webinars, and we greatly appreciate your responses. Finally, this webinar is being recorded, and your TAM can make the recording link available to you. After a few months, the recording will be publicly available on the VMware TAM Services YouTube channel. That brings us to today's speakers and topics. Francois and Luca are with the VMware Cloud Foundation Technical Product Management Team and have a focus on networking components. Francois will be up first and is covering migrating from the nVDS to VDS, which is a prerequisite for upgrading to NSX 4.x. Francois, please go ahead.
Thank you very much, and good morning, good afternoon, good evening, wherever you're located. So my name is Francois Tallet. As just said, I'm in the VCF Technical Product Management Team, and I'm here with Luca, who is up here, and in my team. Jing has made a little part also in the I will present after my section. She's unfortunately sick right now and cannot present, but she has an important part that we'll go over today. So let me quickly move to my topic, and I'll cover Jing's after this one. So this is about upgrading from nVDS to VDS, and as it was already said, it's really something that is now mandatory in order to reach NSX 4.0 because the nVDS has been deprecated in NSX 4.0. So you need to perform this migration in order to upgrade to NSX 4.0. So my agenda is relatively simple. My first part that I called history is just to try to justify our different virtual switches, why we started from a VDS, introduced the nVDS, and moved back to the VDS for NSX and vSphere environment as a whole, I would say. The second section is going to insist on the configuration model differences between a VDS and an nVDS. And this is an important part because this is where most of the complexity of the migration procedure from nVDS to VDS is coming from. In fact, it's not that complex. And I think that once you understand the difference between the two switches, it's actually quite simple. Then we'll go over the migration procedure itself. There are many ways of doing this, some manual, some scripted by you, some using a migration tool that is embedded in NSX 3.x also. And finally, I have a short recorded demo showing you from the vCenter point of view what's happening when you are doing a migration. So let's start with my history part from the VDS to nVDS and back. So there are two main components in a VDS. When you talk about a VDS, we refer to either without really specifying which one is which. So I would like to focus a little bit on that. There is first a switching component on an ESXi host. This is a code really that is switching packets on the ESXi host. That's what I will call also a host switch in the rest of this presentation. And the other part, which is also called VDS, is in fact the VDS configuration that lives in vCenter. So again, the VDS is the combination, the real VDS is a combination of both parts, but we tend to say VDS in vCenter when we talk about the configuration and VDS also when uh, talking about the ESXi component that is switching packets. So I'm not going to talk about the vSphere simple switch that came before the VDS. Let's just focus on the VDS for now. So with NSX, we introduced a new virtual switch when we released NSX at least, called the NSX Virtual Distributed Switch, or nVDS. The name was engineered so that it included VDS inside of it so that our customers are familiar and comfortable using it. And indeed, the VDS, as it is running on the ESXi host at least, the nVDS is pretty close to the VDS anyway. So this is something that has been built on the top of the VDS. I'm going to go a little bit more into the detail. But it is using a different model than the VDS in the way that it was supposed to be independent from vSphere. And this capability of running an opaque a switch inside an ESXi host independently of vSphere, meaning that not calling directly APIs on the ESXi platform. This capability has been introduced several years before we created NSX. In fact, there used to be a Cisco switch, an IBM switch, or a lot of third-party switches running on the ESXi host that were relying on the same set of APIs that made them completely independent from the ESXi host. And this is what we call opaque networks, in fact. And they were using those opaque network APIs in order to run their virtual switch as an independent entity on the ESXi host. And we wanted to do this for NSX because we wanted NSX to be a platform independent of vSphere. Not that we wanted to go away from vSphere, but we wanted NSX to be networking platforms that can be instantiated anywhere on ESXi, on KVM, in the cloud, etc., etc. So our nVDS has been deployed, has been conceived to be independent on from vSphere and more specifically from vCenter. So now check the little green box on the left of this diagram. How to create an nVDS from a VDS? Well, it's simple. We clean up some stuff. We remove whatever was vSphere specific, and we added some NSX specific code for our overlay and all the features that we have in NSX. So the reason I'm showing this is to show you that it is still based on, at least on an ESXi host, because it's the nVDS is different on, let's say, Edge or KVM or any other platform. But on an ESXi host, the nVDS is really based on the VDS, and that's why the name nVDS makes sense. So now in terms of configuration, we cannot rely on vCenter anymore again because we want it to be independent from vCenter. So the configuration has been centralized on the NSX manager. And I'm going to split this configuration in two parts. One that is equivalent to the VDS configuration that was in vCenter. That's what I represented in green and I call generic VDS configuration in this diagram, and the red part, which is really specific to NSX. And I'm even listing more specifically the feature I'm talking about because those are the ones that are going to be important for our nVDS to VDS migration, is that more specifically what I consider what is a generic VDS configuration are the port channel, the LAGs, link aggregation groups, the MTU configuration of the switch, the LLDP status, whether you enable it or not, and NIOC, which is network I/O control, a vSphere feature for, let's say, QoS and packet prioritization. So those components are now configured on the NSX manager. They used to be on vCenter. And of course, you have some very NSX specific parameters that are the tunnel endpoint IP addresses, a transport VLAN on which we send overlay traffic, and the name teaming policies that are our way of making teaming policies in NSX. It's not per segment or per port group. It's global. So here are the components that are um, at hand right now. And let's see why we moved to back to the VDS and what is the implication. So why did we choose to now run NSX on a VDS instead of an NVDS? Well, first, um, it is much simpler to install on an ESXi host. You have to imagine, and I guess you know that from practical experience, even when you move from the VSS to a VDS, you need to move your VM kernel interfaces for management, for example, from one virtual suite to another. This is complex, and there is a very good guided workflow in vCenter to do that. When we introduced the nVDS, we had to replicate this capability without relying on vCenter, and it was all guided from NSX. And even if we made a lot of progress among the different release after one release after the other, we never reached the simplicity that was already available in vCenter. So um, most of our customers, in fact, running NSX are running NSX on ESXi, and moving back to the VDS makes things much simpler for them because they just need to install a VDS, and then the installation of NSX on the top of the VDS is straightforward, and we benefit from all the tools that have been created over the years on the VDS. Compatibility with third-party application was also an issue. I talked earlier on about this opaque network and the way our virtual switch and NVDS was leveraging those new APIs that were independent from ESX. Fact is, the vast majority of third-party developer didn't take this kind of model, those API into account. So for them, um, when running vCenter, they were only checking for two kinds of network: a port group, which is a VSS-based port group, or a DV port group, which is well, the VDS version of the port group. They should have taken into account opaque network, which is what NSX and those previous third-party switches were using. They didn't. So we were breaking a lot of third-party application using the opaque network, and we wanted to go back to a DVPG-based model for our representation of NSX. Finally, I mean, this is purely internal, but um, the nVDS and the VDS are very close, and it's the same networking team, engineering team that was managing both inside VMware. So by moving nVDS and VDS together, we're also saving a lot of effort for our engineering team that had to basically maintain two separate switches. So what we did, look at the box now on the left again. We start from an NVDS. How do we run NSX on a VDS? Well, simple. You add back the vSphere specific code that was removed when we created the NVDS. So the reason I'm showing this is to comfort you, to make sure that you understand that the new model running NSX on VDS has at least all the capabilities that were on the NVDS. In fact, we are now a superset of both the original VDS and the NVDS. We're a combination of both capabilities. And the other very important consequence, and this is why I'm spending so much time explaining this, is that now we have our switch configuration that is split between vCenter and the NSX manager. Basically, anything that we had stolen from the original VDS in order to create the nVDS was given back to the VDS. And all those parameters you see here are going to be configured in vCenter on the VDS. And you will still have to configure the NSX specific part on the NSX manager. So it's a little bit weird. And it's not too bad when you think about it. However, this part that was given back to vCenter could have been configured slightly differently on the NSX manager than it can be configured on vCenter. And the next few slides are going to highlight this because this is again the complexity, the only complexity we have to address when doing the migration. So when you consider an NS, a VDS, there is a single VDS global configuration that is applied to all the host switches. Each and every host switch on ESXi 1, 2, 3, etc., up to well, all your ESX switches running this VDS Bob here, they're going to have the VDS Bob configuration exactly, that's going to be exactly the same on each and every VDS. So there is no difference, and that's probably why we say VDS Bob and we confuse the host switch and the configuration. It's because it's uniform, it's the same configuration everywhere. Unfortunately, we were very clever when we designed NSX and the nVDS, and we offered a lot of flexibility. Basically, this monolithic configuration of the VDS seemed like a limitation for our engineering, and they created a lot of different profiles that allows you to configure the same NVDS in different ways on a per host basis. So the profiles, I just given them numbers here, but those are global configuration that exists in the NSX manager. And when you prepare an ESXi host for NSX and deploy an NVDS on it, you're going to pick a subset of those profile as the configuration of this host switch. So for example, I can have this configuration 1 that is using profile 1, 3, 4, 5, 6, or another configuration that is a grouping of 2, 3, 4, 5, 6, for example. So those two configurations are pretty similar. They only have one profile difference. But however, that can all be applied to the same, well, to what looks to be the same NVDS switch Bob across multiple hosts. And you see that the hosts have different configurations. So it's same switch Bob, but different configuration on per host basis. And there is such a variety of profiles and combination possible that you cannot even assume that two ESXi hosts have the same configuration for a given NVDS Bob. In fact, it means that there is no such thing as a global NVDS Bob here. It is a collection of individual configuration on a per host basis. So you see that it really conflicts with the VDS model where there is a single configuration. You have on one hand a single configuration on the VDS that is applied to every host, and on the other hand, the NVDS, which is a collection of configuration and the resulting configuration on a per host basis can be different. So that's basically the kind of conflict we'll have to solve when moving from NVDS to VDS. So for example, here, suppose I have those two configurations that are applied to two sets of two ESXi hosts. And let's say this is the same NVDS Bob in theory. I want to convert this NVDS Bob into a VDS. How can I do that knowing that the VDS can only have one configuration for all the ESXi hosts? Well, you have two choices, and that's basically everything you'll have to work on during the migration. Option 1 is that you're going to merge the configuration of NVDS Bob so that it's a consistent configuration, and then you have a one-to-one mapping between your NVDS and the VDS that replaces it. That's one model, one option. The other option is that, well, you had two different configuration. It was supposedly one NVDS. You're going to create two VDS because you have two configuration and each VDS can only have one configuration. So that's the other option. And I would say you're going to pick one or the other depending on how important this difference is. For example, here, if this is just an LLDP configuration difference, and remember LLDP is part of the parameters that moved back to the VDS, then probably you don't really care and you can merge all this. If this is something more consequent, like a different lag configuration, which is relatively complex and has implication on the physical infrastructure, then you might want to split your NVDS in two VDS. The reason I highlighted the different parameters that belong to vCenter and NSX Manager is that this merge or split of configuration is only necessary for the parameters that move back to the VDS, because it's a VDS that expect a single configuration. If you have inconsistency in the parameters that remain in NSX, there is no problem, because NSX can still configure those parameters in a different way on a per host basis. So again, to summarize all this, if your nVDS configuration is not consistent across ESXi hosts for lag, LLDP, MTU, or NIOC, you will have to resolve those conflicts, let's say, by merging the configuration or splitting your nVDS into multiple VDS. That's the main things I wanted you to understand going through all those details. So now let's go over the migration procedure itself. And basically assume that we're starting from the minimal network that you see here with two ESXi hosts running an nVDS. I'm not representing the NSX manager here, but right now vCenter is not doing anything. And I want to turn those two nVDSs into a single VDS actually. So the steps are the following. First, you will have to attach your vCenter to those ESXi hosts and create a VDS. Fact is, 99% of our customers were still using vCenter and already had vCenter attached to their ESXi host anyway. So basically, it means create a VDS. At that stage, I've just created a VDS, nothing much. Then what I'm going to do is that I'm going to evacuate. It's a little bit as if I was doing an upgrade of the ESXi host. I'm going to evacuate the VMs from one of my ESXi hosts and put it in maintenance mode. At that stage, I'm going to replace the nVDS that was existing on this ESXi host with a VDS. And the interesting part here, I can exit maintenance mode, and this host is now fully operational in NSX. There is no difference, again, in terms of functionality between running NSX on VDS or running NSX on nVDS. The exact same capabilities are there and then can coexist in the same cluster. So at that stage, I have a fully functional network running NSX, and I can evacuate my virtual machines from ESXi2 to ESXi1 using my overlay network, right? And put my ESXi2 in maintenance mode and do the final conversion NVDS VDS there. And that's it. So all the migration procedures that we're going to talk about now are using this model, basically. Those different steps will be done. It's just that there are different ways of triggering all this. One, and I'm going to insist on that, is that you can do this by yourself by using your own automation tools. I mean, those are pretty simple operations. Preparing a host with a VDS is relatively simple. And you don't need any tool to do that. However, we also have an embedded migration tool inside NSX that will help you do this. And this is a different thing that this tool is doing. So first, let me just introduce the model, the tool itself. It exists in three flavors if you want. Yes.
Sorry, there is a question that I think is worth answering before moving forward. Is there a particular VDS version that is necessary before transitioning from nVDS to VDS? Our current VDS version is 7.0.2. Should we upgrade it before proceeding with the migration from nVDS to VDS?
Yes. So you need at least VDS 7.0. So you're good. You don't need to upgrade your VDS in order to do the migration. So the capability of running NSX on a VDS appeared with NSX 3.0 and vSphere 7. So yeah, you don't need to upgrade your VDS and your vSphere more generally, because the two upgrades are separate. You can have different kinds of VDS, different version of VDS on a given vSphere version. In fact, you might want to do both the upgrade of vSphere with the nVDS to VDS migration. I'll talk about that a little bit later. So the migration tool exists in 3 flavors. We have a CLI that runs on the NSX manager. You can also drive the whole migration via API. And finally, there is a very specific use case with the UI, and this is to club the migration with vSphere upgrade. So 3 stages in this tool. The first is a pre-check. So the pre-check is just having the tool check your environment, discover the nVDS that you have in your environment, and make a suggestion as to how it would replace this nVDS with the VDS. So that's where it's going to tell you, considering your existing network, first, I can do the migration because sometimes it cannot. Or it will tell you, oh, you have one nVDS, I will need to split it into VDSs. Because again, you have some parameters that are not matching between certain ESXi hosts, or it will say I can do everything on a single VDS. Anyway, the point is that it's just going to make a proposal based on your existing topology, your existing environment running NSX. If you don't like this proposal, you can rerun the pre-check again. Of course, you need to make some changes so that it makes the result is different. But for example, as I mentioned earlier on, let's say you have some ESXi host with that are running NSX with LLDP enabled on one host and LLDP disabled on the other. You could merge the configuration and make sure they have the same ESXi same NSX configuration. You rerun the tool, the pre-check again, and then the tool will provide you with a different option now that the 2 ESXi hosts can have the same configuration, for example. So just to say that nothing happens in your network. It's just a proposal. You can accept it, or you can make some changes and rerun the pre-check. The second stage is called apply topology. So this plan that was offered to you, you can decide, okay, it's fine for me. Let's apply. And by apply, it means we're going to create the VDS in vCenter. So that was the first step that I showed in the overall migration steps, right? And at that stage, nothing much has happened. You've just created a VDS configuration in vCenter. Again, nothing has changed on the host switch that are switching the bits, that are switching the traffic on your ESXi. So it's still relatively safe at that stage. Nothing is happening to your network. If you're not happy, you can still go in vCenter and delete this VDS, and you're done. The next stage is the one that is really important. That's where we're going to indeed migrate the host, meaning that we're going to need to evacuate the virtual machine, turn our nVDS-based ESXi host into a VDS-based one, and put it back in service. So the CLI tool and API and UI tool are behaving slightly different in this matter. The CLI tool has a kind of script that automates the migration of the host in the cluster, and that's why it's the most spectacular one. That's the one I'm going to show you in the little demo and in the end. So this tool is going to sequentially put your host in maintenance mode, assuming that there is a DRS available on your cluster. Wait until the virtual machines are evacuated and the host is in maintenance mode, do the migration, exit the maintenance mode, and take care of another ESXi host in sequence. The API version of the tool is doing pretty much the same, except that it is not, it is just called on a given ESXi host, and it's up to you to automate the sequencing. Basically, it's up to you to put the host in maintenance mode, or evacuate the virtual machine manually before putting the host in maintenance mode if you don't have DRS. Call the API to do the conversion. That's the only thing that it will do. And then it's up to you to put the host back in service. Finally, the UA-based tool is just doing the two first steps. It's doing the pre-check, the apply topology. So, and also show you a screenshot of that, meaning that your VDS is ready. But the migration itself will happen when you upgrade your ESXi host from one vSphere version to another. So for example, for the person who asks a question about their 7.0U2 ESXi version, for example, what you could do there is go through the first two steps, pre-check, apply topology. There is some additional steps to perform to do this, but let's say that once you've done those two steps, when you upgrade vSphere, you know that you have to do the same game of musical chair where you put the host in maintenance mode, evacuate the virtual machine, etc., and put it back in service. It will do both the ESXi upgrade, vSphere upgrade, and the VDS migration at the same time, saving you the effort of doing this twice, the evacuation, maintenance mode, etc., etc. So you can club again the upgrade of your ESXi host with the nVDS VDS migration using the UI tool, the UI version of the tool. By the way, I didn't mention it here yet, but I will show you in the reference. I have a white paper that goes into the details of this. I mean, this is just a high-level presentation. There is a public white paper that drives you through the configuration of all this. Okay, so let's quickly go through the different tools, and then I'll show you the demo.
Yeah, Francois, there are a couple of questions that
Sure.
I think that. So first one is, what about opaque networks? Do they go away?
So the opaque network will go away in 4.0 indeed. If you're running 4.0, you will not see opaque network anymore. And if you are running 3.x, it's interesting because you might still see opaque network and NSX DV port group at the same time. Oh, I didn't go into those details, but the main difference moving from there is so much to cover, sorry. The main difference when using NSX with a VDS versus an nVDS, it's not on the NSX side itself. Nothing changes on the NSX side. What changes, the only thing that really changed is the representation of the NSX networks in vCenter. So you create a segment in NSX, segment Bob. I like Bob for some reason. You create your segment Bob in NSX. With an nVDS, this segment Bob is going to look like an opaque network in vCenter. And you can attach your virtual machine to this opaque network. If, by the way, in the same vCenter, you have also a host that is prepared for NSX with a VDS, segment Bob is going to look like an NSX DVPG Bob. So if you go onto this VDS, you will see a DVPG with a little N in the icon that says that it's an NSX DVPG and just the same name as a segment. And you can also attach your virtual machine to this DVPG. There is no difference between the two, meaning that whether you attach your virtual machine to the opaque network or the DVPG is exactly the same, except that, well, you can only attach attach it on a host where it is available, of course. So if you're in a mixed environment where you have ESXi1 with an nVDS, it will only see on ESXi1, you will only see the opaque network, and on ESXi2 prepared with the VDS, you will only have access to the DVPG. But again, it's just a representation difference, and practically in terms of forwarding, traffic forwarding, or feature that you can configure, it's exactly the same. That's also the only difference between the two consumption model is attaching to this network, in fact. The APIs that were used to attach to an opaque network will still work if you use a DVPG. So if your NSX network is still identified by a UUID, I mean, I don't want to go into the details. There is a KB article that clearly describes that, and I put a reference to it at the end of this presentation. But you can still use the UUID of the ID, let's say, of the segment to attach your virtual machine to an NSX DVPG. It will still work. The only difference between the two models is that if you check where your via API, if you check where your virtual machine is attached on an opaque network or an NSX DVPG, it will return something different. So if I have virtual machine Bob again, that is attached to a given segment in NSX, if the representation is an opaque network, it will return an opaque network. If it is a DVPG, it will return a DVPG, but the DVPG will have extra information that identifies the segment and pretty much the equivalent of the opaque network. But otherwise, yeah, sorry for the long answer. Opaque network are going away because they're a representation of NSX segment in and with nVDS.
Cool. Yeah, there's another one is there any consideration if the nVDS is used for distributed firewall only?
nVDS cannot be used for distributed. Oh, hold on, sorry. Let me
Or
go back.
VLAN, yeah,
Yeah.
VLAN.
So with VLAN segments, yeah,
Yeah.
because we have another version that is running on VDS. So well, it is the same thing, but the parameters you're talking about are much simpler because you don't have the NSX specific parameters. It's only well, no, in fact, it's not helping. You still have the potential conflict if you have a host that is configured for lag, let's say, and another one for the same nVDS, a host with configured with lag and the other without lags. You still have the same migration procedure to perform, but it's honestly, you're most likely not going to hit those kind of issue. In most cases, the conversion is pretty straightforward. But again, sorry, not again, but in the end, your host, your virtual machine is still attached to an NSX segment. So even if it's not an overlay segment, it's going to be an NSX DVPG VLAN backed. So the segment is still looking like a DVPG in the VDS. It will have this little N in front of it. So it's not because it's an NSX DVPG that it's overlay. It could be overlay or VLAN, just like you can have a VLAN segment or an overlay segment. That's the only difference.
Yeah, I mean, I guess there's the last question. Just asking for confirmation that all the configurations that are available on the nVDS will be migrated as equivalent to the VDS by the tool.
Yes, well, the tool is not migrating it is migrating the configuration that is relevant to the VDS. Yes. It is going to basically create a VDS with the equivalent configuration as the nVDS it replaces. And again, the configuration we're talking about are just what I listed. The lag, LLDP, and IOC, and I don't remember what is last one. But it's not much, the MTU. So yeah, it will create this automatically. There are additional stuff that it does behind the scenes. I didn't talk about. For example, if you have a transport node profile that is applied to a cluster, it will create an equivalent transport node profile for the VDS, etc. But yeah, it's taking care of everything.
Thanks, Francois. All clear.
Okay, so we're almost to the end. At least on that, I'm taking more time, but I think we have time. So the pre-check. So I'm on the CLI of the NSX manager. I run my pre-check and I get an ID, a nice UUID. We love UUIDs here. That says, oh, we've created a topology for you, and you can show this topology using the command VDS migrate show topology. And this is not super user-friendly, but the kind of information you're interested in is the name of the VDS it's going to be creating automatically for you. So you could potentially change this. It's super complex at that stage. What I recommend is that you just go through your migration and then you edit the name in vCenter. It's super simple this way. But just bear with the name that the tool has created for you during the migration. So it has created, it is proposing the creation of this VDS. It is telling you that there are two VM kernel interfaces that needs to be migrated. So that's very important, because if you're running on an nVDS only based network, your management interface, your vMotion interface, your vSAN interface, whatever VM kernel interface is, they're going to be attached to a VLAN segment because there is no DVPG there. So what we need to do, what the tool will do for you, it will create an equivalent DVPG and move those VM kernel interfaces to this DVPG. And finally, you have the lists of the transport nodes that are involved. So I have a super simple lab with just 2 hosts. So that's what you see here. When you're happy with your topology, here I'm happy. I have a single VDS for my 2 hosts. It could have been 2. I'm applying the topology, which is just going to create the VDS in vCenter. And finally, I start the migration. This is initiated on a per cluster basis. You can put the name of the cluster, and it's going to do the migration on this cluster. I'll show you a recorded demo for this, so just hold on to this. Now, the API tool is doing the same steps, but with API, obviously. So the pre-check is pre-check API. And you check the pre-check with another API called is get check ID. So this is going to return a nice UUID, and you put it back there, and you get the result. Same JSON format as the one I showed you earlier on. There is a little variation that is interesting on the API tool, is that you can do the pre-check per cluster. So you can do the migration on a cluster only. The CLI tool is considering the whole environment. So it's not that much of a difference, because with the CLI2, you run the migration tool on your whole environment, but you practically do the migration on a per cluster basis by calling the migrate procedure on a per cluster basis. So it doesn't mean that you have to upgrade, migrate all your hosts at the same time. But you still have to create the pre-check for the whole for the whole environment. Whereas here, it gives you the opportunity to create a pre-check only on a cluster, and that could be useful. That could actually be your only choice if the migration tool, if you have multiple clusters and there is one cluster where the migration tool cannot run. There are some very few drawbacks where it cannot run. If it cannot run there, then you can do it by cluster using API. Then you apply the topology. Again, it's a matter of creating the VDS automatically for you using this API call. And finally, and I already mentioned this earlier to you, you'll have to go over all the ESXi hosts, make sure they're in a maintenance mode, and call this API in order to automatically configure them with a VDS. So again, you could do all this manually, but the single API call on a host in maintenance mode is going to remove the NVDS, and replace it with the equivalent VDS that you had created during the pre-check and applied. So finally, the UI-based migration tool, you access this from the quick start. That's this one, prepare host for migration. And it's very simple. Basically, you do the pre-check by clicking on this button. You get your topology here. That's the name of the VDS that is suggested. And you have the list. You can click on there and see the list of all the hosts that are impacted. Here you could change the name. Here it's user-friendly. You can change the name. And the final stage is performed when you do the vSphere upgrade. So there is no migrate button here. You will have to do a vSphere upgrade for this nVDS to VDS migration to happen. That's all I have. And now let's go quickly over the demo. So this is my lab with two ESXi hosts running an nVDS. So very simple. Each of those ESXi hosts has one VM attached to a segment called overlay segment. And that's the only segment in my environment, so it's very simple. You'll notice that I have two other opaque network here. This is a representation of an opaque network. One for vMotion and one for management. That's where my VM kernel interfaces are attached. I mentioned that earlier on. They're VLAN segments, and that's where my VM kernel interfaces live. So I'm opening a window on my NSX, a shell on my NSX manager, and I run the pre-check. I get back this beautiful UUID as a result, and I can show the resulting topologies. That's pretty much the one I included earlier on. So you see that I have one suggested VDS with this name. I'm going to migrate two VM kernel interfaces, VMK1 and VMK0. And this is a list of the transport nodes that are impacted. And I'm going to start the migration immediately. So I have a DRS configured, so everything is automated. And you see that, sorry, I'm not doing the migration. I'm doing apply topology. Apply topology only creates the VDS. I'm one step ahead. So you see that automatically in vCenter, the tool has created the VDS that was in the topology, and it has also created some port group, some DB port group for the management and vMotion. This is the uplinks, the VDS uplinks. So you see that we've already created automatically the equivalent of the VLAN segments where the VM kernel interfaces were attached. There is no equivalent for the overlay segment. You don't need to do that because the overlay segment is still going to exist on this VDS once it's prepared for NSX, and we'll see that later. And you see those operations happen automatically in vCenter. We didn't have to do anything. So now I'm calling the migration tool on the compute cluster, and you see that already something happened in the background. The first host was put in maintenance mode, and the virtual machine are being migrated. So I have to admit that this is not in real time. I did not accelerate. I just chopped off. I edited the video so that you don't have to go through the painful migration of all this. It takes some few minutes actually to migrate those two hosts. But you can see that at a given time, the virtual machine are always connected to their segment. They're just being flipped around between hosts using vMotion. And in the end, this is how our virtual switch looks like in vCenter. You see that we have our two VLAN DVPGs. Those are real DVPGs, sorry, the standard, what we call standard DVPGs. They're not in NSX, they're in vSphere on the VDS. And you have this overlay let's say NSX DVPG. You see, same, it's not really visible. There is a little N on the bottom right, and that says that it's a segment that is handled by a DVPG that is handled by NSX. And this will appear everywhere. You used to have this opaque network, that's the replacement for this network in the VDS. It's that simple. So that's all for my NVDS migration demo and presentation. I would like to just reiterate the two following points. First, the migration tool is not the only way to move from NVDS to VDS. You might have to do a manual migration or migrate, well, do your own automation for this migration. It's not that bad when you think about it, because the tool is not necessarily covering all the possible scenario. You wouldn't believe the corner case we run into and that are not covered by this tool. But again, the tool is not the only way of doing this.
And
Yes,
Francois,
yes,
the community .vmware.com has been migrated to community.broadcom.com, and
correct.
you may not click. If you click this URL, you may not reach the right destination. So I have posted it in the chat box.
Oh, good, thank you.
The community yeah, if you don't find a document, probably you have to figure out some monkeying way until the migration is complete. But since May 6, community.vmware.com does not exist, you have to go to broadcom.vmware.com.
Yes. Thank you, Nimish. So it exists. I checked it. Actually, it's stupid. I didn't update the link. I even re-uploaded the documents to Broadcom community. So you'll find it with a name, if not with a link. But I think the link will still redirect you to the right place. The KB article also is going to redirect you to the right place. So the KB article is going into the detail of what is the difference between an opaque network and an NSX DVPG, the kind of question we had. So this is, I put a lot of details in this KB article. It looks like a white paper. And the other one is a white paper more focused on the migration itself, and it gives the same example step by step for all the tools and even the manual version. So have a look at it. So if you don't have any additional question on this, I will move to the part from Jing. Any other question? So yeah, we took a lot of time. I expected to be much faster. Sorry about that, but okay. So this part is about some automation, some operation capability of NSX. And we have a quick recap of what is available and in the latest NSX release. So I'm just going to go over some few features that are available and you might not know about. And I will end up with a nice NSX playbook that Jing created and pushed also on communities. I think she updated the link. I didn't think about that. She did. Anyway, so first, let's talk about the live traffic analysis. So this is a very powerful tool to understand the traffic patterns inside your NSX network, and more specifically, the NSX overlay, to be honest with you. So we already had trace flow. I don't know if, let me describe trace flow quickly. Trace flow is the capability from NSX to inject a packet at a VNIC from one VNIC targeting another VNIC, or let's say a physical, an IP address in the physical network. And the way it works is that NSX is going to create a packet. You have several options. Send it as if it was transmitted by a virtual machine. So the virtual machine itself is not doing anything. We're going to inject a packet from the virtual NIC of this virtual machine as if the virtual machine has transmitted it, but it's not the virtual machine, and that's very important, that is transmitting the packet. It's NSX that injects this packet. The packet is typically sent over overlay, and in our encapsulation, we have a bit that says trace. Basically, this bit NSX use an encapsulation called Geneve. I guess you're aware of that, which Geneve is basically equivalent to VXLAN with an additional field, an additional type length value field, where we can insert our proprietary information, basically the metadata of the packet that we need for NSX. That's the beauty of Geneve that compared to VXLAN. So we have a bit that says trace this packet, and the packet is injected by NSX. It's going to be switched across a different NSX component in the network. So for example, it goes from an ESXi host to an edge, then to another edge, and then back to another ESXi host where the target is located. Thanks to this trace bit in the overlay, NSX is capable of collecting the packet wherever it goes through in the NSX environment, centralize all this, and give you a nice history of where the packet went through. So this is a very powerful tool already because it tells you where your packet go, if it was dropped by an access list, if it's been natted, or anything that can happen in NSX is visible with TraceFlow. So this live traffic analysis is one level beyond TraceFlow. Basically now we have the same capability, but instead of NSX generating the packet and injecting it in the VNIC, we're going to capture the real packets generated by the virtual machine. And so basically what it means is that you'll have to define which virtual NIC you want this operation to be performed on. You will have to tell basically how long you want this to last, how many packets you want to capture. You have several options. You can even filter the kind of packets you're interested in. And we're going to use the same trace bits in order to see where this packet that the virtual machine has sent is going through the NSX fabric. And we also have the capability of capturing those packets and storing them in a PCAP file that you can use with Wireshark, for example. So this is very powerful because actually, I've hit this. Let me give you an example that I hit myself. It goes beyond one step beyond TraceFlow. I recently in my lab, I had a virtual machine that couldn't ping another virtual machine, and I quickly did a TraceFlow, and TraceFlow worked. So I was like, my TraceFlow is working, meaning that the path in NSX is working, but my virtual machine one cannot ping virtual machine 2. So NSX works, but those two virtual machines couldn't talk to each other. And with the packet capture, I did my ping again with packet capture, and there I could see that I had messed up my default gateway on my virtual machine. So you see the difference, right? With the traffic injected with NSX, the MAC address of the default gateway was correct. But with my misconfiguration on the virtual machine, the default gateway was wrong and my packet was going to the wrong direction. So this is the kind of stuff you can get with packet capture. We have very powerful tools for observing the traffic path in the network. That's all I needed to say there. So we have a lot of improvements in terms of upgrades. At every release, we make our upgrade model more efficient. Our first upgrade of the management appliance is our NSX manager, were all upgraded at the same time, which resulted in a short downtime while the NSX manager were upgraded. In 3.2, we introduced the capability of doing rolling upgrade within the management cluster, which means that you can upgrade your NSX manager the one after the other, which means that during the upgrade, you still maintain the quorum. Your cluster is available. It's much safer, and you can even do a rollback easily if you need to stop at any time. So this is kind of little things that are introduced. Another enhancement is that in our first models, we were upgrading all your edges in your NSX environment, then all your hosts, and then the managers. And you can have a network where you have different zones, different availability zone, or different just areas in your network where you have, let's say, the production network, which is a set of hosts and a set of edge, the QE network, which is a set of hosts and a set of edge. And because of this initial model, your upgrade was impacting both production and QE at the same time, for example. So in 401, we've introduced the capability of grouping the devices that you want to upgrade. So you could make sure that you upgrade QE first by upgrading the edges and the host in the QE environment before you upgrade, let's say, your production network when you have a maintenance window, etc. So we have the capability of grouping the different elements. And again, at last, we upgrade the manager cluster, but this one is not disruptive. In 4.1, we introduce a very powerful online diagnostic system, which is really a support tool when you think about it. If you've ever had to contact VMware support, if you end up with a problem that is relatively technically challenging, you end up having some engineer getting access to your machine and running some complex command on them that you don't understand and that I don't understand because they're engineers and there is a lot of complexity that is not exposed to the user, hopefully. So the idea of this online diagnostic system is that instead of always needed some support engineer to log into your box and collect some information, how about we have some scripts that are already created by support for some specific scenario that run on your device, collect the appropriate information, and allows you to provide this as a bundle to support. And in 4.1, we started introducing this model. So you have embedded in NSX a collection of runbooks. I'm going to show you a list of what we have. A collection of runbook that you can invoke, typically based on the direction of support, honestly. So you can initiate the runbook, get some information as a result, and even download some files that this runbook has created. And today we have 17 runbooks. I'm not going to go into the detail of them. There is a URL that tells you exactly what they are and what they do, but that gives you an idea of the benefits in terms of troubleshooting. It simplifies the work from support, obviously, and yours too, because you don't have to provide access to your support engineer in order to troubleshoot in a very deep way certain types of problems. In 4.1 and also in 3.2.2. 3.2 is a long-lived release, so it gets some features typically in its maintenance windows sometimes. So you will know that NSX is capable of attaching to multiple vCenters as compute managers. That was a goal of NSX in the first place. It was supposed to be the networking platform for multiple vCenters, right? And multiple environment and beyond vCenter, actually. So this is a well-known capability, but in 4.1, we introduced the capability of actually attaching multiple NSX manager to the same compute manager, to the same vCenter, which was not possible. Earlier on, a given NSX vCenter could only be onboarded, if you want, by an NSX manager. So thanks to this capability, we can have a vCenter that spans across two different NSX environments. So those are completely different NSX environment with different managers, different edges, different everything. And on a per cluster basis, so it's not on a per host basis, on a per cluster basis, a cluster can belong to a given NSX manager or another NSX manager. So if you want, it's a little bit as if you could split your vCenter, and certain cluster of this vCenter are going to an NSX manager, and certain the other part, the other cluster are going to the other NSX manager. So additional flexibility. We have very few customers using this, honestly. Async upgrade pre-checks. So this is an additional capability that allows you to get an idea of whether your upgrade is possible even before downloading the upgrade bundle, the MUB, and running the pre-check. So that's like a kind of a pre-checks, if you want. It will allow you quickly and without network connectivity to get some indication in the state of your environment, and know if you can consider an upgrade. When you start the upgrade, you will download this MUB, this upgrade bundle, and you will run a more detailed pre-check again. But that's a quick benefits, a quick and easy way independently of your NSX version, and without downloading the MUB to check if you're ready. So this was introduced recently in 4.1.1. So finally, that's almost my last slide. I just wanted to touch on VCF, because VCF is a solution that is using NSX, and it is using NSX. It is providing a kind of guided design for your environment, and it is doing its own lifecycle management of the different components of NSX, of your environment. So more than just NSX, it does the lifecycle management of your vCenter or your vSAN, etc. So as a result, VCF doesn't have integrated all the low enhancements that I listed earlier on in NSX, and there are some stuff that are yet to be implemented. But the benefit you get is that you're getting the management of your whole VCF environment. It's not limited to NSX. So just going over the bullet list here, we don't have the in-place upgrade yet. It's coming soon, but I cannot give you a target release for that. We don't have the concept of upgrade unique group. So basically, the VCF upgrade lifecycle management of NSX will consider the whole NSX network, not a group that you could manually create. And also, the upgrade of a cluster is done serially in sequence on a given cluster. So you have less flexibility as what you had with NSX, but those features are coming, like this async upgrade pre-check I just mentioned. It is coming in VCF, but it is a little bit late because again, VCF is built on the top of NSX, so you have to imagine that the feature are first released in NSX and then make their way into VCF. That's basically the idea here. So I'm going to show the last slide, which is a very nice document that Jing has created on communities. And I have the link here, and Jing is clever. She updated her link. I didn't. But the operational playbook is an Excel spreadsheet that allows you troubleshoot main common problems in NSX. And I'm going to switch to this quickly. So I'm in Excel and just show you the kind of thing that you can do. So it's basically a big troubleshooting guide that you can see it this way, but it's nice in Excel because you have a hyperlink to the different parts. So for example, if I say that I want to troubleshoot my edge, I have some concern or question about the edge. I'm clicking on the Edge tab, and you're going to see some information about a typical Edge VM deployment, for example, and that the kind of physical representation of the virtual machine. You have a logical representation of how the gateways are used in NSX, because typically, of course, your edges are used for running tier 0 and tier 1 gateways. And you have a list of different issues that you can check. So for example, let's say check tunnel interface and status. So if I click on there, I'm reaching directly to the section that is giving you the kind of debug command that you can run on the edge itself and also on the UI. So it's very exhaustive. You have a lot of different. You have the packet walks. This one is very nice, where she has colored the different fields so that you can identify what is overlay, what is inside the encapsulated Geneve packet, etc. So I encourage you to download this. It's available in communities. I'll put the link back, and you can play around. Even if you don't have a technical issue, I think that's a very good training material. So that's the last slide I have, and I'll hand it over to Luca for the exciting certificate part.
Yes, but before you go,
Yes.
there is a question that gentleman asked and I could not answer, but maybe he can reframe that question. It's in the, let me rephrase the questions. He's talking about the nVDS to VDS migration. The way he's asking is saying, so this only touches NSX back segment and NSX VLAN back segment inside the VDS. So as we do have another DVPG trunk port for our BGP neighbors for upstream connectivity, and he's putting a question mark.
Sorry, I didn't get the question.
I started to answer the question, but maybe we can clarify, because
Okay.
the question was like, if that migration tool, as far as I understand, affect only the VLAN DVPGs in a VDS, but of course it doesn't really affect them. If a network, it is a VLAN or an overlay already on a VDS, it won't be part of the scope of the tool. So we will only affect any workload that is connected to an opaque network on the nVDS. So if something is already on a VDS, if it is a VLAN DVPG or an overlay DVPG, it will stay. It will not.
Yes. So yeah, I'm not sure exactly the exact context, but think that the VDS that is created is a new VDS anyway. So you're not touching any existing DVPG if you're concerned about an existing DVPG. This new VDS can have what we call standard DVPGs, which are just regular DVPG for VDS, and we create those for the VMK interfaces. That's the only thing that we create automatically. Then after that, it's a matter of knowing what transport zone your VDS is attached to. So I didn't go into those details, of course, but a VDS, just like an nVDS, is attached to a transport zone. As soon as you're attached to a transport zone, you will get all the segments that are visible in this transport zone, whether they are VLAN segment in a VLAN transport zone or overlay segment in an overlay transport zone. It is
Francois,
yes.
I gave your email address.
Yes. Yes.
So
Okay.
you're a private connoisseur for the nVDS
No problem.
VDS migration. So reach out to him directly. Yes.
Yeah, no problem. Thank you. Okay, I'll stop sharing.
Yep.
All right, let me start sharing. I will share my entire screen, as I'm planning to do some live demos for this. So this brief last section, we are going to talk about the changes in certificate management that we made available in NSX 4.1. And the reason we decided to include it as part of this session is because you're going to see some changes in how the certificates are presented for the NSX platform after you upgrade. And the way they are presented and what is shown is different than what you have seen so far up to NSX 3.2, and you may have some concern right after the gate, after the upgrade. So this last part is really about concern, kind of addressing those concerns. But really first start and to explain what did we do in 4.1 in terms of certificate management. The reason we change the way we manage certificates in 4.1 is to address, of course, some of our customers' requirements. One of the requirements, of course, is really from a platform compliance and security perspective. The customer wanted to have all the communication channels in our platform. That is, of course, a distributed architecture with NSX manager, controllers, the different transport nodes. So all those components need to talk to each other, and we want to ensure that all those channels are encrypted and secured. Also, some customers have the requirement that to control all the certificates that are leveraged to secure those channels. So in up to 3.2, some of those internal communication channels were encrypted using hidden certificates. So some customer wanted to have control over them, so we started to expose them. Also, we have support for newer encryption algorithm based on elliptic curves. And also, we did some changes to the default validity of some of those internal certificates, because at the beginning, previous to 4.1, we couldn't change them. So we, by default, set them to a kind of a long validity, like 10 years, so that kind of customers, you didn't have to kind of be concerned with them. But now, because we can replace them, we shorten really the lifetime of those certificates. So there are those changes. I mean, because of those requirements, we made a bunch of changes on how those certificates are really presented. And really the goal is to enable our customers to kind of fulfill some security and compliance requirements based on different framework that may be available, specific to EAL4. So, but first, let's talk about what type of certificates are we talking about. So I'm going to go to one of my systems here, and I got an NSX manager, and you can use OpenSSL to go and query the certificate that are available on different ports on the NSX manager. And if you didn't really dig deep into the certificates that are exposed by NSX manager, you will always be aware of the certificates that are exposed by the UI and the API that are, of course, exposed on port 443. And we see here that we have a certificate, and the common name for my lab is this one. But what happens is that some customers kind of run their security scan over our platform, and doing so, they discover that there are other certificates, like, for example, this other certificate running on port 1234. That is a completely different certificate, as you can see here. And that is used for this internal channel between the transport node, like the ESXi host, and the NSX manager, for example. So so far in 3.2, you didn't have a way to see them in the UI, but now those certificates will be visible. Okay, so let's go back to the slide 1 second. So in NSX, we have so many all those different channels, and you see, for example, that up to NSX 3.2, we also add some unencrypted channels, like on port 8080 for the installation of NSX on our transport nodes. Those are being replaced to support encryption for all the communications. So, and you see there are a lot of flows going between the different components, between the transport nodes, NSX manager. If you have federation, also there are different communication channels between the global manager clusters and the local management clusters, and all of them use different ports and different certificates. So in 4.1, now all those certificates that are leveraged by these channels are exposed in the UI, and also their default validity is been lowered. So kind of now you cannot really wait 10 years to replace them. So if you do a fresh installation of NSX 4.1, you would have these new certificates that are short-lived. But what happens if you are just doing an upgrade? And to show you that, I had a really kind of old environment that I think was this one here, and I decided to upgrade. And what happens is that, and this is what could happen after you upgrade in your environment. You will see those certificates appearing. So you see that I have a lot of expired certificates in my UI, nothing really to be concerned with, and I'll clarify why. But those certificates have been there forever. They've been generated when you first install the platform, could be in NSX 3.2, could be in NSX 2.5, depending on when you install the platform, and they've already been there. It's just that they were not exposed yet to you, and you didn't have a way to replace them. But the system have been able to support all the communications with those expired certificates, because the expiration check was not really enforced. So the idea is that what should we do? So the first thing is that we shouldn't be too worried when you see these expired certificates, because they are not direct cause of concern, because the expiration check is not enforced by default. So what happened and what we've seen with with customers, especially when they were doing upgrades early on to 4.1.0, they may have some problems, maybe caused by the upgrade or not. And after they see that there are a lot of expired certificates here, they kind of start focusing on replacing those certificates right away. And they may not be really the root cause of the issue that you're having, because in general, as far as we can tell so far, those expired certificates don't really cause any issue. But of course, you want to replace them. So I'm going to show you how we can replace them. So there are different types of certificate, and this kind of a system with a lot of the fresh install of 4.1 with all certificates are valid. So there are a lot of new certificates. Some of them are for inter-component communication, so between host and NSX manager, for example, but some of them are even certificates that are used internally to a single NSX manager appliance. So for example, let me see, can I highlight here? These Corfu client certificates here. Those are certificates that are used internally by the platform for different software component on the appliance to talk to each other, specifically to talk to the Corfu database, that is the shared database that is running on our platform. So all those different components use those certificates. And by default, you see that they have really long live expiration by default in 4.1, but they may be expired in your installation because you come from an older version. So how do we do this? So we have a new API. So the replacement of the certificate can be performed only through API. We are going to show you that we can generate a certificate directly in NSX Manager, and we can do that in the UI. But in order to actually apply this certificate to a specific service, we need to use this specific API. And you see these, there are different parameters that you need to specify in this API. You have the certificate ID, so the specific certificate that you want to use. You also have the service type. Service type represent for what is the purpose of the certificate. It could be for the API that is presented for the user. It could be for the synchronization with the global manager, for the communication for the transport node. And you have here the list of all the supported services. Also, you need to specify the node ID, because the node ID is the node ID of the NSX Manager cluster member, because each individual NSX Manager appliance will have specific certificates for the different services. So depending on the certificate that you are replacing, you will have also to specify on which node you want to replace it. So how do you get this list? Of course, you can take this slide or really look at the documentation, but really the most authoritative way to find out what are the certificates that you can replace on your platform and your specific version is leveraging this API, the kind of list all the certificates profiles on your certificate profiles are kind of specify what are the certificates that can be replaced on your platform, and also what are the requirements for that certificate. For example, for the management cluster profile, service profile, that is the service profile that is mapped to the VIP certificate of your NSX management cluster, we see that the extended key usage for that certificate should be server, because this certificate will be used as a server certificate for your clients for UI or API. There are other certificates that are clients. So for example, any internal service that will authenticate against Corfu, those will be actually client certificates. But this is kind of a little bit abstract, so let me show you kind of an example of how to perform this replacement. And I'm going to do this on this 4.1 installation that I upgraded from 3.2, I think. So for example, I want to replace this expired certificate here. So for this monitoring, the service monitoring is a Corfu client certificate. So the first thing I need to do is generate a new certificate. I can generate a self-signed certificate. It's no problem. I'm going to call it new monitoring. I don't need to specify anything else. It doesn't need to be a service certificate because any platform certificate, they need to have this flag disabled. The validity of the number of days that I can set, the maximum is 825 days, is something that some of our customers don't really like because they would like to have some long list certificates so they can do this once and just forget. But as an industry standard, we have to limit the number of days that those certificates can be valid. If you want to have longer lived certificates, you need to generate them outside of the NSX management platform and upload them to NSX. It's fully supported, but if you generate your certificates directly in NSX, as I'm doing right now, the maximum lifetime of those certificates will be 825 days. So I'm generating the certificates, I'm clicking save. So now let's find it where it is. New monitoring is here. So I'm taking now the ID of this certificate, and I'm going into Postman, and I'm going to do my apply certificate API call, and I'm specifying the ID that I just found for the certificate. Apply certificate, and then I need to specify the service type. To find the service type, I'm using the get certificate profile API, and I'm going to search for monitoring. I just did before. Here you go, and the service type I can see is CBM monitoring. So I can go back to apply. So I can change, I can do it here directly. It's the same as changing that in the URL itself. And also you see that I need to specify the node ID for which I want to change the certificate. If I go to my NSX, the way you will find out the UID of your node is into Fabric, appliances. And because this is a simple setup with a single NSX manager, I have a single NSX manager appliance. But if I was a 3-node cluster, I would have 3 of them. And what I can do is go to view details, and I take the UID from here. And I would paste it here. It should be the same, hopefully, because it's the same. Yes. And now I can do a send. Okay. So I can go back to my NSX. Certificates. And see that now new monitoring, the certificate that we just created, now it is in use, and it is in use for the CBM monitoring service. And we can also go and check the old one. And now should be, yeah, this one here. You see that it's not in use anymore. And because it's not in use anymore, we can even delete it. Okay. So let me go back to my slide deck. So besides those certificates that are present on the NSX manager themselves, we also have certificates that are on the host transport nodes and on the edge transport nodes. Again, those certificates have always been there. We always had an encrypted communication between our transport nodes and the NSX management cluster, but now we have the ability to replace them. And kind of one thing to consider is that by default, in previous version, those certificates had a 10 years lifetime. So if installed in 2.5 or 3.1 or 3.2, kind of those certificates will expire 10 years after the first installation of NSX on the specific transport node. But if you install new transport nodes in 4.1, those certificates will have a shorter validity of 825 days. In this case, for these certificates, we don't really manage them directly in the NSX UI, so they are not visible in the UI, but we have a way to replace them using the NSX API rather than going directly into the NSX, the ESXi and edges themselves on the transport node themselves. When we do the replacement of those certificates must be generated not on NSX. And the reason is that when we pass the API call, we also need to pass the private key. And if we generate a certificate onto NSX Manager, the private key is not exportable. So you need to generate the certificate on a different platform, maybe using OpenSSL, and then upload that private key together with the certificate onto NSX Manager. And then NSX Manager will push the certificate and private key down to the host, onto those two, and you can double check them onto those two locations onto the host. Unfortunately, at the moment, there is not an easy way on the UI to see what is the status of those certificates, but we have alarms. So if there is a certificate that is going on a host that is expiring in 60 days or 30 days, you're going to see an alarm in NSX. But those certificates, again, are not really visible in the UI. So I'm going to now do a demo, I guess, of how we can do this in replace those certificates. And to do that, I'm going to introduce this document that is available on Broadcom communities, but right now, gamer communities, it's not in great shape. So if you need it before it is fixed, please reach out to your technical account manager. They can provide you a copy. And basically, this is a document that I created that is a bunch of kind of recipes on how to manage these certificates in 4.1 with a lot of scripts and API calls kind of to automate all this kind of overhead that now you have in order to manage these certificates. So there are recipes for different use cases for the NSX Manager, for the transport nodes, but a single cluster, single node cluster, so singleton, 3-node cluster, federation. So many different use cases are covered. But in this case, I'm going to go to the recipes for my transport node certificates. And I'm going to go here. And I'm going to use the script. So this script, this script just simply use curl and API calls. We require the transport node UUID of the transport node where I want to replace my certificate. So let's go to a system like this one. And I'm going to say, I'm going to replace my certificate on this transport node, this ESXi 1A. So what I do is go into my fabric nodes. And I'm going to take the UID of that specific transport node as a host. This one here. Copy ID. So then I can go back to that script. And now the script is kind of ready to run. And before I run the script, I want to check the certificates that are currently there. You see that in this directory, you have the private key and the certificate here. We can also see the certificate that is currently in use. I mean, the details about the certificate. And you see that this certificate was created on May 2, when I tested this lately. So May 2, so a couple of 5 days ago. Now I kind of go back and try to replace this again. I just copy and paste the script. The script will generate the certificate on my jump host and then push it to the NSX Manager API. See, it works. Generating the certificate and pushing it. So now if I go back to here and check the certificate file, it should be a new one, hopefully. Yeah, you see that it has been just created. So this is the today's date and this time. So you see that kind of you have those certificates that we can manage centrally and change the change the certificate on the host directly on NSX Manager, but we don't have really a way to kind of view them from the from the UI. There is a way to kind of, because for these are the certificates that are here are only the platform certificates running on the NSX Manager. I found that there is an API that we expose that we can use to identify the lifetime of those certificates. And for example, I'll show you the output of the script that again is available on community. And this script will kind of pull all the certificates that are available on the API and kind of generate and provide a report around when the validity of the cert. So you have kind of right now, we don't have this information available in the UI, but through the API and this script, you can have a report about when those certificates are going to expire, and so that you can plan for that. And back to my slides. Let's see if I still have. Okay, really, I'm at the last session, last slide of what I like to present, and this is probably the most important. And kind of, I don't know about the questions, but kind of those are the most critical questions that I usually get from customers, and around what are the impact of if those certificates are expired. And really, the answer depends on the type of certificate. So the first line is about the common API and UI certificates that you are used to. For those, if they expire, is not really critical in the sense that, of course, you will see an error for any client that is connected to NSX Manager. But unless you have an automation system that requires to trust the certificate and is pushing configuration to NSX, it will not really break your environment. So if your consumption is simply through the UI, you will have that annoying SSR error, but nothing more than that. Of course, if you have consumption through automation that rely on the certificate, things could be more impacted. But in general, it's not a highly critical problem if you have those certificates expired. More critical and kind of very critical are the certificates that are running on port 1234 and 1235 that are the management and control plane connectivity of the transport nodes to the NSX Manager. Really, you don't want them to be expired, because if they expired, we don't have a way to replace them, because we can replace them, but then the host that it was trusting the old certificate will not have a way to automatically reconnect to the NSX management cluster, and you will have to manually go over the node and reconnect and trust the new certificate. So really, the second row here is really important, that they do not expire and you keep an eye on them. The third category, those are the APH certificates, and those are the certificates that are used for the synchronization between global and local manager for the control plane. Those certificates are long-lived if you come from an older version, so they are 10-year old, but they are only 825 new if you start with a 4.1 fresh install. Those are really critical if you are doing federation. They are not critical at all if you are not doing federation. The problem with this is if they expire right now, we don't have a way to replace them. So basically, we need to kind of offboard, re-onboard the LM. So this is the current situation if those certificates expire. Then we have the local manager and global manager certificates. Those, again, are other certificates related to federation. Those are kind of principal identities that are used by the different clusters to authenticate against each other. For example, that there is an enterprise admin principal identity user that global manager used to push configuration to local manager. For those, there is no impact. If they expire, doesn't really matter. This is based on 4.1.1. Things may change in the future. But so even if they expire, not really a concern. You can replace them through the normal procedure that is documented. Those CBM certificates, those are the software components that talk to the Corfu database. And those are those that are going to pop up in your environment after you upgrade. You're most likely going to see a bunch of them expired. Those are not critical if you're coming from an upgrade and we have a configuration knob that kind of determine if the expiration check is enabled or not for those certificates. This is disabled by default on any system that is pre-4.1. So even if you have all those certificates expired, is not a problem. But if you enable that knob for whatever reason, or if you are in a new, 4.1 or later version as your first deployment, this will be a high impact, and kind of the NSX manager itself will not be operational. Transport node certificates, those that are 10 years by default if you're coming from an old version. So really the certificates that are on the ESXi or the edge, the impact is high because those transport nodes will not be able to connect to NSX manager if they are expired. So the best option is, of course, to replace them through the API or the script that I showed you before they expire, because that process, of course, will only work if there is a trust relationship between the manager and the host, and those updated certificates can be updated over that trusted channel. If not, you can replace them manually, going on the host itself, doing a copy and paste of the actual private key and certificate, and then we have a ESXi NSX CLI command to push the certificate and trust the new one. All right, this is it for me, for my part. I think we are kind of a little bit slightly over time, 10 minutes. So if there is any question that I need to answer live, please let me know, or I can take a look.
Yeah, there are a couple out there. There was one question about the certificate replacement and if it had any impact on the data plane when certs were expired.
On the data plane, no, because in general, those are concerning management plane and control plane. If you look at take a close look at that document that I shared with the certificate cookbook, there is a specific CBM certificate that is impactful from a management plane perspective. It is called the CBM management plane, because it will restart the management plane of the node where you replace the certificate. So what happens is that if you do that on one node at a time, very, very carefully, nothing will happen, because of course we have the built-in redundancy in the NSX management cluster. But if whatever reason, like you replace them at the same time on two managers at the same time, like I was doing when I was firstly developing the scripts, yes, you will have a problem. Basically, your control plane and management plane will be down. So if you are automating that replacement, that should be done in a careful way. I mean, in my scripts, in my sample scripts, I create a pause statement, so kind of that makes you check if that specific certificate is kind of I mean, the replacement went through and all the services are back up and running. Yeah, it is painful to be using API all the time. Yes, and yeah, we absolutely are working on this. So basically in 4.1.1, we introduce all these capabilities and to kind of give you more flexibility to replace certificates and expose them. But at the same time, now we realize that we immediately realized kind of the burden on the user to kind of life cycle and do all this work. So there's a lot of work going on that should be available soon, kind of to simplify all of this, and all those workflows will be available through the UI in a future version. Are the certificates replaced based on an upgrade? No, this is a very key concept. So the certificates are never replaced automatically, and the certificates are generated by a process called cluster boot manager at the beginning when you first install NSX, and they are never replaced unless you do an action, and the actions are those that I showed. So that's why you may end up with those expired certificates when you upgrade to 4.1, because they appear expired because they've been generated when you first installed NSX, maybe 5 years ago. They maybe had a default lifetime of 3 years, and now they are expired. Can one cert be used for all the transport nodes? We need to verify that. We are working on reducing the number of certificates that we expose in NSX and can try to reuse individual certificates for multiple purposes. So specifically for transport nodes, I don't think we have a clear answer if we can have the same transport node certificate for all of them. But for sure, we can have a single certificate for all the Corfu client, CBM Corfu client cert. They all can share the same certificate as long as it is different of the certificate of the Corfu server. So that because all the communication never go to client, they all go to client to server. So as long as client and server are different, it's fine. But I don't have a clear, definitive answer to the fact that kind of different transport nodes can use the same. I don't think we validated that. Right now, all the environment that we test, those are unique certificates. And yeah, I don't see any more question open, so I think
yeah, it looks like all of them. Definitely appreciate you guys hanging in there and covering so much ground. It was really really great session today. So thank you so much for the presentation. As we mentioned at the beginning, this presentation was recorded and your TAM will make that available to you. Please join us next month when we'll be looking at what's new with vVols and core storage. We look forward to seeing you for that session on June 6th. Thanks.